Hello everyone, thanks for joining the webinar. And today we will talk about DIY streaming Lakehouse on Iceberg, what they don't really tell you in blog post. First of all, I actually write a lot of blog posts. I share a lot of yeah, things well transparently, and I do not really hide anything. But I think that will I mean definitely something that will I feel that will probably there's a lot of details I didn't really share in the blog. And if you check some other people's blog, they definitely have great insights, but definitely there are some other yeah, I don't know whether it's called dark secrets or it's yeah, first-hand information, right? Well, and yeah, detailed information they probably didn't really share. And we can talk about this in this webinar. So first of all, let me just introduce myself, right? For just one single slide. How to Okay, so I'm Yingjun Wu, and I'm a founder of RisingWave. So as I mentioned, well, I was from before starting the company 4 years ago, and I was at it was Redshift, and Redshift is the was the data warehouse. At least when I was there, it was like a data warehouse. But now if you check, well, yeah, no, okay. I just checked when it's still a cloud data warehouse, but well, definitely these days where people talk about a lake house, and that's why we're here today. And prior to Redshift, I was from research world and academia world from IBM Research Amazon and a PhD. Yeah. Okay, so Eric, it's your time.
Yeah, hi. Yeah, my name's Erik. I'm the director and founder of Hivemind Technologies. We're a tech consultancy based in Europe, like London and Berlin. And we've been basically working in the streaming and data platform world ever since we started like 10 years ago, helping clients build their and migrate their workloads to data processing, modern data processing architectures in the cloud using cloud technologies, predominantly cloud technologies. And we basically went through all the different innovation cycles from like batch workloads on Hadoop, then moving on to Spark, then adopting streaming first strategies and helping clients realize the gains and the benefits of Lakehouse architectures. So yeah.
Cool. Cool. And so okay, so today's talk is all about Iceberg, and I believe that's what everyone knows Iceberg is. But Eric, could you please just to give me a quick pitch on why to choose Iceberg? Oh, actually, tell me something about it. Yeah, what is Iceberg and why to choose Iceberg?
Yeah,
Just
so
assume that I'm
Iceberg,
a customer and I have no idea about what Iceberg is, but just to give
yeah,
me.
so that's actually quite simple, right? So if you just think about how we used to do things, essentially in the Hadoop world, it's basically just, having one big batch job, process lots of stuff, right? Maybe like over the course of a couple of hours, and then write an entire table somewhere in an object store in a bucket, and then put it there, and then you could query it and do things with it. But that was it, right? And the only problem, the major problem with this approach is that you can't just add or modify data unless you rewrite everything, and
Mhm.
that usually means rerunning the entire job. As time went by, you had like a few more efficient formats, like Parquet and also Delta, uh, tried to fix those problems and also offer some abilities and some features that would allow you to rewrite partial aspects or make some modifications. But in essence, all of these approaches fell short, and Iceberg came about with the promise of creating an open, easy standard, piggybacking on approaches that were pioneered by Delta and Parquet, and create a format that allows you to do continuous updates and upserts onto your data sets and reorganize and compact your data sets within a single format that's open and that can be adopted by many people. And that's the last part is really, really interesting because Iceberg is widely accepted as the predominant open table format. There are others, obviously, but it's the predominant one. And you'll find connectors and integrations everywhere. That's a very compelling approach to organize long-term storage cheaply and efficiently.
Yeah. Yeah, totally, totally. And because you work with so many companies, right? Well, tell me something about who should consider adopting Iceberg. And so in you have so many clients and
Mm.
tell me about okay whether it's like startups. I'm not sure whether you work with startups actually, but I mean whether enterprises or Snowflake users want to move to Iceberg or it's more because well probably they came from the Hive world, right? Well, Hadoop guys probably adopt the Hive first and then
Yeah.
consider okay moving to Iceberg. What's the who should consider adopting Iceberg?
Yeah, the interesting thing is that you basically have like two groups. First of all, we do work with startups or more specifically scale ups and big
Huh?
enterprises. Interestingly enough, like the middle tier, like middle-sized companies it's a growing sector, but it's underrepresented in our roster of clients. And the interesting bit there is that you
Is there
basically
any
have
specific
like
industry? Is there is there any in a specific industry like energy, like a manufacturing?
yeah.
Yeah.
So we do have like the two main groups that we've got are obviously industrials, right, and
Uh-huh.
energy, because obviously with the rise of IoT and some other megatrends like digital twin legislation regulations, it becomes increasingly important for companies to track everything that they do across the board
Hmm.
and to process that data for reporting purposes, observation purposes, or things like predictive maintenance, et cetera. So there's a huge pressure to invest in that area or to migrate existing workloads into that sector. So a lot of our clients, they're basically are looking to modernize their offerings, move away from relational databases or classical warehouse solutions to like more scalable formats that offer better bang for the buck, if you want, right? So better capabilities in terms of query performance and near real-time ingestion patterns. So that's quite important. Now and then you have the a classic streaming bunch, everybody that basically all the industries that rely heavily on transactions that can be commerce, finance, advertising. They're like big users of streaming and large like data platforms with Hadoop workloads in the back that need to be modernized. So essentially, you have like those two groups. It's about modernization or setting up data platforms from the get-go and migrating them away from, let's say, classical warehousing systems. Yeah, but to come back to your original question, well, what's the main use case?
Hmm.
Yeah, like the first use case really is if you have Hadoop, if you have or anything similar to Hadoop, and you have workloads that are running in either in a classic managed platform like Cloudera or even AWS, or you're running workloads in Databricks or Snowflake. Well, they tend to be expensive, especially because constant reprocessing becomes really, really cumbersome and expensive in terms of like load and transformation workloads. And you're raking high bills. Iceberg is one way to really cut costs significantly. We had one project where we had like a spend of 300,000, and we just cut it down to below 70K just by making that switch, right? So it's significant the amount of money that you can save by just also harmonizing the ingestion pipelines into a continuous format that makes it easier also to handle, right?
So you
So
just so you
yeah,
basically drop the price from 300K to 70K.
70K. Yeah,
70K
that's not
because of
that's not
moving.
uncommon, right? That's not
Okay.
uncommon. And sorry,
Yeah,
please.
yeah, yeah. Why? Why you can save so much money?
Well, first of all, like the problem is that it's the you rake like big bills because everybody all the users of the data platform all struggle to get their data. They all need some projection of the data set. So they just create the same similar workloads across the board to produce the similar data sets just for themselves. And because it's batch, you basically have continuous chains of reprocessing. And a lot of that is just superfluous, right? Because you're basically regurgitating the same data over and over again. And it's not anyone's fault, right? Because people just need the data and they just say, well, hell, God, am I going to coordinate my batch workloads with somebody else? I need this stuff so that I can do my job, right? And that basically generates like huge bills, right? Because you're basically just doing the same stuff over and over again in a very inefficient way on top of it because essentially each ingestion pipeline has to reproduce and reprocess the entire data over and over and over again. So that's not really a surprise that that's expensive. And on top of that, they're using platforms that have significant cost associated to ingestion pipelines. Thinking of Snowflake, Snowflake is great, has great features, but the one thing that's really expensive is everything that has to do with Snowpile and all the ELT stuff. Each time you just run it off, it just it breaks the bank, right? At some point. And if you can just eradicate that by having Iceberg as the landing format, where you can query Iceberg tables straight out of Snowflake rather than having to do an ELT job, that already saves a lot of money.
Yeah, so definitely. Well, I mean, Snowpipe. I heard a Snowpipe for a couple of times. For actually many times, because
Yeah.
if you're a Snowflake customer, I mean, definitely you want to have, yeah, you want to have a something to ingest the data, some pipeline to ingest the data from somewhere, probably from your, I don't know, Postgres, Oracle into Snowflake. Then you probably have to use Snowpipe, and Snowpipe is super expensive, right?
Yeah. Yeah, it is very expensive. Yeah.
Okay. So actually, I also talked to a lot of customers, our customers, and definitely, yeah, we collaborate on some customers who we talk mention about that for later. And I actually summarized some reasons people what that triggers people to move towards iceberg. I think we're in so first of all, I mean there are probably we have already discussed. Well, I mean there are two groups of people. One came from the Snowflake world, or probably BigQuery, right? Well, I'm not trying to blame Snowflake, okay?
No, 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 really. It's
Yeah,
just an example.
Snowflake is
Absolutely.
great.
Yeah,
Snowflake
yeah.
is great. But well, I
It is
mean,
great.
yeah, one type of the customers came from the, let's say, Snowflake, BigQuery, or whatever, right? Or the data warehouse world, and basically cloud data warehouse world, right? Well, they changed the name to Lakehouse. And then the other type of the customers came from essentially came from Hive world, right? Well, basically Hadoop, Hive, and Next, I
Yeah,
think, right? And then I found that well, the Hive guys will never complain about for the cost. I mean, they were complain. I can talk about that later. But for Snowflake
yeah,
guys, well, actually, they complain a lot about what they cost because well, it's really, really expensive. As you just mentioned, well, I mean, Snowflake actually charge you based on the number of virtual warehouses, right? Or basically the
yeah,
hours, right, where you run. But the thing here that you have to sometimes, well, you okay, they pitch you about, well, look, what Snowflake pitch is like, okay, just do ELT, right?
yeah,
Just to transform your raw data into Snowflake, and then you can have all the raw data there. But the problem here
yeah,
that's if I just store raw data in my Snowflake, then the problem is that well, I have to continuously or repetitively process my raw data. So that's when my data becomes useful, right? We'll talk
yeah,
about that later, right?
precisely.
Um,
Mhm.
so they complain a lot about the cost. So essentially, that's definitely a trap. And
Yeah, interestingly enough, it's not only Snowflake because the traditional vendors are just have the same problem, right? So if you're thinking of Informatica, like MicroStrategy, Tableau, you have on a smaller scale the same ingestion issues as well, right? So it's really just across the board. Um, Thinking about the traditional warehouse world can also benefit from moving to Iceberg.
yeah, yeah, and another reason is that well, I find that well, because well, Snowflake is too expensive. Let's say BigQuery, data warehouses, okay, the cloud data warehouses are so
Yeah.
expensive. People, okay, people think about okay, let's try to avoid vendor lock-in because well, typically when you first if it's your first year using yeah, no matter what kind of data warehouses you are using, you probably get probably a volume discount. 10%,
Exactly. Yeah.
20%, 30%. I told one of my friend told me that's where they actually got 40% from Snowflake. It's a pretty big customer. But well, anyways, that's some yeah private offering. All right, and that's I mean, try to avoiding vendor lock-in has become the main motivation because well, I mean, for next year, let's say that's where I want to negotiate with Snowflake, have to have some leverage, right? So that's the
Yeah.
second thing. And the third thing, a third reason is that well, I feel that well, people really want to have the open data access. What it means that well, let's say that's well, I want to share my data with my colleagues. okay, definitely you can use Snowflake, right? But for the thing here, that's what let's say that's right. What if I want to share my data with my external organization, right? Or some other organization? Yeah, Snowflake has a concept called for the yeah, they also have the marketplace, but I mean, I sometimes I just want to share freely, right? And also the other thing here that's well, I mean, even if you say that's okay, that's we can also share data in Snowflake. Then think about it, okay, what if I want to use let's say the pandas or use let's say my okay some polars, right? So polars is another Python library and some other
Mm.
libraries, right? Or TensorFlow, whatever, to access my data. There's no way to directly access data in Snowflake because it's Snowflake's data format. You actually have to copy the data, create another
Yeah,
copy.
exactly. You have to copy it out again, which is like crazy, right? So it's like
Yeah, that's
in
crazy.
order
Yeah,
to be
that's
able
crazy.
to use something else, you just have to land it somewhere, which is again the batch chain problem, right? That's where you land, right? Exactly. Totally.
Yeah. And another reason here, that's why I found that's what people really want to do so-called streaming and batch processing. It's probably not because of the yeah, Snowflake, everyone knows that's why it's the batch-based system, right? But
Mm.
but what people I mean come from let's say the streaming world, right? Well, they are like okay, just do streaming. So as you mentioned, well, okay, nowadays, well, what people does it as well. I mean, they actually have to use snowflake what yeah snowpipe, which is
No
super
pipe, yeah.
expensive. So in order to ingest the data into snowpipe, or actually have
Yeah.
to probably find some other solutions, right? Um, so which reason you think that's why it's probably the biggest one that that triggers people to move towards iceberg?
I think like
The
in
people,
this economy
yeah.
with all that uncertainty, like I believe just that flat out, it's always the money, right? It's just because one of the main reasons why people choose warehousing or lakehouse solutions in the first place is that there's that promise of saving money, right? You save developer cost by having comfortable self-service tools. And it's true, Snowflake and others, BigQuery and Databricks are very comfortable. If you're like a data analyst or data scientist, it's fairly easy to use the tools and it's really comfortable, right? And to a certain extent, that money argument, that's how you basically get onto that bandwagon. But
Mm,
eventually, as usage increases, and that's also the reason why these companies are successful financially, well, the bills, you start racking up like high bills, and
mm.
then the businesses are starting to pose the question whether you're essentially getting really good value for money. And that's when you start reconsidering whether that is, let's say, dumping everything into one of these cloud lakehouse solutions is the right strategy, or whether you want to have a more bespoke and more, let's say, measured approach to this problem by saying, okay, well, we're keeping the data
Mm.
elsewhere independently in an open format, and we're still using those solutions, those cloud warehousing solutions, but we're telling them, okay, you can use this by accessing the iceberg tables, but we're in control. We do not need to have to load the data in and out, and you're not basically absolutely married to that platform. And
Ownership. That's ownership.
that's something that we're seeing also in the considerations, the strategic considerations with our clients. They're thinking about these things a bit differently, and but because in the first step is always to drink a bit the Kool-Aid of the vendors and say, okay, well we're going to dump everything in there, and that's going to be solve all our problems, and to a certain extent it does. But as soon as the true cost comes into play, uh, there are some readjustments that are necessary.
Mhm. Cool. Definitely, yeah, okay. So yeah, we talked about so many about well, the I mean the reasons, right? Well, let's just mention let's just discuss well one of our shared customers, right? Well, actually the first customers we collaborated on, right?
Yes,
Well,
right, exactly.
what's the name? It's the first customer we collaborated is actually Siemens, right? Well, Siemens is a very classic well I'm not sure whether
Yeah.
it's the biggest enterprise company in Germany, but well,
Mm.
definitely everyone knows what Siemens does, right? Well, and they actually They use here Snowflake and probably some other databases, and they actually moved towards Iceberg, right, tool. And Eric, could you show me tell me something about okay when you started working with Siemens and what their journey looked like?
Yeah, yeah. So we started working with Siemens like years ago, so it's a bit difficult to tell.
Pretty
We've
before
done
COVID?
quite a few projects with
I don't know.
them. Like probably I don't know, after like probably like 4 years ago or something.
Okay, okay.
In any case, we've done several projects with them, all in the streaming space, and one of the projects had essentially a classic integration workload about, it was about moving data, replicating data from legacy enterprise systems to their Snowflake-based cloud, right, offering, and that is essentially what they wanted to do. And we started the project with different approaches, and we built an end-to-end pipeline using streaming technologies and targeting Snowpile specifically to ingest the data into
Oh.
Snowflake.
Mhm.
And that worked quite well, right? And that we were already using RisingWave to do the ingestion bit, and we can also talk about the benefits
Yeah,
later
we
when
can
we
talk about that part later. But
yeah,
let's
about the
talk about
medallion
the icebreakers.
architecture.
Yeah.
But generally, the interesting thing was that in the first iteration, we were using Snowpile, and that costs a lot of money. And then, in order to essentially, optimize the cost structure, we decided to go to Iceberg because obviously, there's a huge push across all vendors to support Iceberg, and Snowflake is no exception. And in this case specifically, we can just bypass the Snowpile ETL process by just landing the stuff as Snowflake table, I'm sorry, Iceberg tables, and that is represented in Snowflake as external tables that you can just query. So you basically circumvent the problem of ELT,
Yeah.
and because it's already basically there, right? And that essentially just cuts all the transformation costs that's associated with producing the data, landing it somewhere, and having essentially Snowflake looking at the same data again and just copying it into their proprietary format. You just basically circumvent that problem, and that makes it much more efficient because you can still use Snowflake for all the great stuff that Snowflake does, right? In terms of data analyst, data processing and reporting, etc. But without essentially that first bit of ELT that is so expensive to pay for. Yeah. So I think
Yeah.
that's a really interesting use case there, because it combines, especially again in this economy, it's always a good thing to be, because we don't know, what the trade stuff is going to look like in in a year or two. It's always good to be prudent and to see if we can optimize the cost structure
Yeah.
without changing anything to the actual technology that you want to do and the goals, right? So
Yeah. So yeah. Anyways, well, yeah. So definitely, I also overlooked the entire journey, right? Well, at the very beginning, actually, we were not working. I mean, when we first started collaborating on this project, well, I mean,
mhm.
actually, Siemens case, well, we were actually not working on Iceberg. We were working on
Yeah,
something else, right? Well, it was
exactly,
like moving from Flink to RisingWave. And
exactly.
well, that's they moved from Flink to RisingWave because of different reasons, because of the
Yeah,
streaming joins, because of all these costs, right? And so
yeah.
Flink couldn't handle that part, well, so they moved to RisingWave. But
Correct. Yeah. Yeah.
that was actually 2 years ago, and
Yeah. It was 2 years ago. Exactly. It was
yeah.
interesting
Yeah, so
because
we
that
started working on that project for 2 years ago because well, okay, and I still remember that well, we spent a lot of time working on optimizing the let's say the joins, right? Well, because
yeah.
well, I mean, their join is super complicated because well, it's from the either from the power plant or from the
No, no. It's like it's a, like a database of material records. So there's a lot
yeah,
of
okay,
moving things. So
okay,
it's
mature
not
records.
energy, right?
Yeah,
But yeah, no, it's just
okay.
essentially a lot of data across the board, right? With a lot of projections. And the interesting bit, and the reason why we started with Flink in the first place, is that we just wanted to basically be able to generate via code generate the views automatically, not having to handwrite them because it's a lot of different views. And Fling had some significant computational issues with that. I mean, where they've caught up now. So, but it was so much faster and easier to do with Rising Wave, right? So we never looked
Uh,
back then.
yeah, that was 2 years ago, and then they yeah they mentioned to us about the cost of the Snowflake, right? So
Yeah,
it's not definitely not of a business, right? So it's Snowflake cost right now. But what I think here that's what I mean. Essentially, we're definitely not Snowflake experts, right? So we're not like helping people. I mean, but what I think here the interesting fact is that over the last 2 years, what we can see is that everyone is pushing towards Iceberg. And even
yeah,
for Snowflake, they actually also mentioned that this is part of Iceberg. So that becomes the opportunity for us, right? Well, essentially, we actually, Eric, you did a lot of efforts in helping them to move towards Iceberg. And
yeah,
then, but the issue here, that's what they essentially at the very beginning, they actually used a Snowpipe to ingest the data
yeah,
from,
exactly. Right,
yeah,
right, right.
from the data warehouse, from their operational database, which is a pretty
Exactly.
old database, right? And ingesting to Snowflake. But for in order to ingest, if you want to shift your data storage into Iceberg, you actually have to find some other pipelines, right?
Yeah,
So that's why RisingWave becomes the data ingestion tool
yeah.
for the Iceberg.
Yeah, exactly. So the interesting thing is that like from the get-go, even just doing the transformation classically from a SQL legacy SQL database into Rising Wave using CDC and then into Kafka and then using another connector to write into Snowflake directly using Snowpipe. That was already pretty cool, right? Because we could have an instantaneous and continuous ingestion, which otherwise would have been much more difficult. But the real but that costs obviously because you basically have to pay for a lot of moving parts, right? You have to pay for the infrastructure and legacy side. You have to have significant Kafka setup to do that. And there's Debezium, and you have Rising Wave then, and then you have again the transformation process to Snowflake. And in the new version, we can simplify all of that because we can and that's a weird thing for us to say because we're big fans of Kafka, but in this setup we could get rid of Kafka altogether because we essentially just can just do CDC native CDC with Rising Wave from the SQL database, and then pipe that into Rising Wave straight into Iceberg, and then load that the Iceberg expose the Iceberg table in Snowflake as an external table. So we the infrastructure involved gets much simpler, and everything that's more simple also is less expensive. So it's really good.
Yeah, definitely. So and I know that's what in not just the Siemens case, but in all all the other cases you mentioned frequently about what the you talk about frequently about what the architecture called what is called.
Yeah, it's a medallion architecture.
Yeah,
So
medallion architecture, right? Well, and
exactly.
yeah, what it means.
Yeah,
And is
I'm
it
going to
like
explain
just
that.
like a buzzword, or it's more like
Yeah,
people?
it's more a concept than anything else. And the interesting and credit due where credit is due. It's a concept that was popularized by Databricks. I know we've been
Database.
hitting
It's
them a bit lately, but indeed with with Delta Lake, their predecessor format to Iceberg. They basically popularized that concept that you have like three different stages in a data platform, bronze, silver, and gold, right? So, and what that is, if we go to the next slide, I can explain briefly. So bronze is essentially the concept of landing the raw data. Wherever it
oh,
comes from, if you just, you can have multiple sources. I mean, let's say you're continuously ingesting stuff from CDC from a database, you're getting material orders from third-party suppliers that just dump CSVs in a bucket. And you may also have Salesforce data, maybe some stuff from SAP, like purchase orders and whatnot. All of that, you just land that into that raw data zone, which we call bronze. So it retains the original structure in bronze. We retain all the original structure as is, so we can do recomputation if we want to, and we just keep it. We keep it because obviously the concept of modern data platforms is that storage should be cheap and we want to keep the long tail. However, bronze is not very useful because as that's just having bronze is basically having a Hadoop cluster of old, because you basically have to do batch reprocessing of all the stuff that you need each time you need it. And that's not really great. So in Medallion, if we go to the next slide,
Mhm.
we have silver, right? And in silver, we basically do data cleansing and enrich the data and join the data that we get from bronze, and we provide a cleaner, consistent representation of the data set. And the most important bit that we do there is that we also normalize different entities of the same type, but with the different schemas. So for one case that we're going to talk about later is in the EV space, right? Vehicles, and they have telematics box on board, and we get the same entities like telematics events, but from different providers, and they have different schemas, and we want to normalize all of that. That's what we would do in the silver layer. We basically take all that stuff and convert that to a common schema, so we can represent all the entities of a type in a uniform format with all the enrichment and calculation and conversion that's required. So that's silver. And then we come to gold, which is on the next slide. And that's where we basically do aggregated and transform data representations for end users. So in gold, what we want to do there is to especially take all the silver data and create materialized views. And let's hold on to that name for a bit to be able to say, okay, guys, this is what it looks like. You can use that in your report. You can use that in your queue, your published queue to other users, or you can use that to aggregate incoming data sets in your front-end applications. Gold is like really important. That's the serving layer for end users. So it's a very, very simple approach, right? With three different layers. Traditionally, all of this happens in batch, right? So you have a batch process that lands the stuff in bronze, and it just ingests that and pushes that up to silver, and then you have the gold transformation. But of course, that's not what we want to do in a streaming lakehouse, right? So
Yeah,
um,
yeah. So in the past, well, all these three layers were in Snowflake, or yeah, right? All this
Snowflake, Databricks, AWS, Spark,
and
whatever. So
and
it's
and
quite tech agnostic. It's just as it is. It's an approach. We
yeah.
used to do at Hivemind. We used to do that a lot just with Spark, right? So yeah.
Yeah. But for this, I mean, with Iceberg, we can basically store everything in Iceberg, right? All this
And
really.
that's the cool thing about this, right? So this really cool thing, because that's where we bridge the gap between streaming and batch. We do not in traditional formats where you use Parquet or Delta or whatever, it's all batch because you do a lot of reprocessing and you have to rewrite everything all the time. And Iceberg really changes that. Right?
Mm-hmm. Oh yeah, definitely. Yeah. So if people do not really, yeah, actually our topic is also about what the streaming lakehouse, right?
Mhm.
So definitely we can dive deeper into the streaming lakehouse because so yeah. So the question is that's what I actually have is as well how we do this kind of things right in Iceberg because well I fully understand how to do this right in Snowflake because well, you can just repeatedly query the same data, right? Do the same transformation, right? Well, again and again and again, right? Well,
Yeah.
my build
Yeah,
probably definitely
in
get.
Iceberg, the interesting bit is that you're not basically tied to a schedule. You do that computation continuously from a stream, right? So you basically have a Kafka ingestion stream, for instance, or you have like in RisingWave, you have a streaming table, and then you just do that computation continuously as the data comes in, and you update and you do upserts on the Iceberg table. And that's
Yeah.
really cool because you have a representation that looks and feels like a table that you had with Delta or Parquet. It looks the same and feels the same, but it's continuously updated uh, as the ingestion, as the records come into the platform.
Yeah, definitely. I think what, yeah, for these slides, yeah, I actually can probably do some introduction about these slides,
Yes,
but
please.
I actually don't really want to spend too much time, right? Well, I mean, our topic is about streaming lake house, but what they think here, that's what I want to mention as well. Actually, 4 years ago, actually 4+ years ago, when we
Mhm.
first started working on the Rising Wave, that was four plus years ago. It's during the COVID, probably the second year of COVID, and
Mhm.
we call it a streaming database, right? And basically it's what is streaming database? Well, basically there are two ways. Well, I always tell people there are two ways to explain it. The first one is that's okay, you can just do stream processing in a database way, right? Well, basically SQL, Postgres, especially PostgreSQL, because we're
Yeah,
writing Wave speak PostgreSQL. It's not Postgres we input, but we are Postgres web protocol compatible. And the other way that's what I mean. We can just do stream processing inside the database. So that's
mm,
a typical the two ways we discuss well what a streaming database is. But well, I mean, as well, I mean, yeah, you really have a pretty good nice slide talk about the rising wave. But basically, original focus was, I mean, still now, our focus definitely scalability, right? Well, latency. I mean, people do use rising wave to do, let's say, not just like say, data warehouse, but probably some people want to do, let's say, trading. For trading,
yeah,
we work with some of the world's biggest trading firms and the banks.
yeah,
Essentially, we yeah like the Japanese largest bank and also the world's largest investment bank, all paying
cool.
customers. So we definitely focus on latency and definitely focus on low fault tolerance and scalability. But what essentially through the time, yeah, as the time evolves, right? People came to the iceberg world, and we started thinking about okay, what a streaming database means, right? So to me, everything should be like iceberg centric. That's number one. That's a rule of thumb, right? So
Mm,
what do we think is that well, we actually need to think about how to architect our system, our help our customers to architect their data infra based on the iceberg. Right. So these days, well, if you check out the documentation, you will find that well, there is essentially a iceberg section discussing how we can ingest the data, query data, store data in Iceberg, right? We're using just the Postgres compatible SQL.
yeah,
That's
absolutely.
yeah, that's what
It's
we do. And then okay, so that's my probably just 1 minute. Oh,
and honestly, just for the record, we think it's fucking awesome, right? Pardon my French, right? Because the thing is that a lot of the work, most of the workloads, transformation workloads, are like very simple, right? And as of old, we used to write programs to do that, either in Flink or in Spark or in whatnot, right? And the fact that you can basically express 80% of your transformation needs just by using SQL and mapping stuff and joining stuff from one to the other. And that's like a majority of all of the Spark jobs and Flink jobs out there just do exactly that. That makes the let's say handling data streams within a data platform so much easier, right? And also more effective specifically. I think that's
yeah,
one of the compelling
yeah.
reasons to use this, right? So
Definitely for streaming drawings, well, there's no better solution yeah compared to RisingWave. I have to say that well, Siemens is definitely one of the giant
yeah,
yeah, right way, and they actually have the very complicated drawing queries and their state. I still remember that where they have the internal state like terabytes of
fuck.
the internal state. Oh, that's your cat.
That was my cat, yes.
Okay, that's cool. Yeah. So yeah, and we actually were and actually we are currently working with another basically probably the worst yeah one of the I could not share the name, but yeah pretty yeah everyone knows the company, and so basically they have yeah, thousands of CPUs running in drawings, and they used to
Yeah,
have the Spark streaming, but unfortunately Spark streaming also doesn't really work for in their case. So they switched to I have already switched to RisingWave. I hope
yeah,
that I can
that's awesome.
share the company name probably the end of this year. But essentially,
Cool.
that's definitely the strength of the streaming RisingWave in terms of streaming joins. But yeah, let's focus on the streaming Lakehouse. And regarding streaming Lakehouse, so what do you do? I mean, just to give me a pretty concrete example, people probably don't really want to listen to about well, okay, hear about well, okay, just the concepts, right? People just want to hear about okay, what's the real use case, right? Well, what do you ever done in the past, right? And what's the customers well the journey, right? Well, and tell me something about that.
Yeah, so this is like the most common use case that we have with our clients, right? It's essentially it boils down to the problem of finding the single source of truth, right? Across let's say ingested real-time data sets and batch. That's a real problem. because and as you know, we have a lot of different let's say architectural answers to that, be it Lambda or Kappa architectures or whatnot, which all have essentially a combination of different stacks and a synchronization of stacks just to represent let's say that uniform approach to batch and streaming. And the good thing with RisingWave, this cat is very consistent. I'm sorry, excuse me, uh, is that we can essentially express everything in one solution, right? You basically have the ability to orchestrate like a streaming ingestion pipelines from different sources, and you can subscribe and query the data sets and essentially expose either, let's say, a queryable table or a stream that you can subscribe from. And that's a real simplification of that, like yeah, the typical Lambda Kappa use case problem.
Uh, yeah, actually, there's one question probably for me. Well, I mean, the raising with skills for multiple concurrent writers against the given iceberg table. I mean, look, well, I mean, if you want to write, let's say, I don't know what concurrent writer means, well, but let's say that's where you have multiple data CDC streams, right? Well, yeah,
Yeah,
all probably have multiple data Kafka streams, right? No matter whether CDC streams or Kafka streams or whatever or
yeah.
even you directly use writing waves inserted into, then typically people need to join this together, right? Well, let's say that's well,
Specifically.
yeah,
That's
yeah,
a
yeah.
real game changer there, right? Because the issue is that you basically often you want to do computation and a representation, especially like in reporting use cases. We want to have a computation of different data sets from different sources. Let's say you have like master data that comes from SAP, and you have like ingested stuff from Salesforce because there's a material procurement process, and you need to join some computation that come from a database that you're just capturing via CDC. All these sources are completely, let's say, alien to one another, right? You can't really build an application, or you have to code a lot to do that in an application. The cool thing about this kind of approach is you can basically just subscribe to all those inputs, right, and combine them into a uniform layer and a uniform approach within RisingWave. And that makes it a very potent solution for those typical data problems that you have in data platforms.
Yeah, so there's a question in the channel, but for yeah, so basically the question is that for concurrent writers, well, it's okay. So it's different workers pull data from Kafka topic and write into a table. So basically about it's more about for the commit coordination. So yeah,
Mhm.
so we implement the same way as the all the other standards for systems does. Well, I mean like Kafka. So yeah, basically, yeah, it's the same. So and we support exactly one. So yeah, it's not a so we are not for have a say some data loss or probably data duplication. You will not have that kind of issue.
Yeah,
Um, yeah, and so definitely we can also mention something. Okay, so yeah, actually we have already discussed this, right? Well,
we've covered that one. We could
yeah,
just
yeah, we
basically move
already
on.
covered that, right? And basically you have the so that's where you have let's say that's where you have that so-called dynamic table, right?
Yeah,
And you essentially can use for continuous query to transform the data into the other dynamic table, right? That's
exactly.
and so essentially, one thing I want to actually, you also mentioned the materialized views. One thing I want to mention is that for officially, the Iceberg V3 spec V3 will be released probably this month or next month. That's the from
Mhm.
the official Apache Iceberg community. Um, it will be released from in this month and next month and or no next month. And in V3, it will officially have the concept called materialized views. And RisingWave natively has already supported materialized views. And so, which means that RisingWave will become the first system that can support Iceberg materialized view, official Iceberg materialized views. But now,
That is awesome. That's
yeah,
really great.
if in V2, if you ingest the data from using RisingWave and create a let's say an iceberg table, let's assume that's what this table is an iceberg table, you can still create material views on top of the iceberg table Why we can do this? Because we actually maintain the we actually maintain a log in RisingWave materialized views, so that will the downstreaming materialized views can consume the logs from the upstream materialized views. So that's the trick we did. But well, I hopefully yeah, we will have the official Apache Iceberg materialized views supported in once V3 is released.
And we're obviously super excited about that because that's really a like a standard use case that we've got with our industrial clients, looking for like the ability to continuously stream out data, the same data or similar data into different representations for the use cases across their corporate structures, and that's really important.
Yeah. So we actually have 10 minutes left, and so
Yeah,
we actually have can discuss something about more concrete, concrete, right? Well, because I know that we have years of experience working in certain domains, right? Like manufacturing, like a EV, right? Let's just
yeah,
talk about the so yeah, RisingWave is definitely SQL, PostgreSQL, and
yeah,
yeah, parallel. Yeah, okay. Actually, it actually answers the question in the channel, right? So multiple
yeah,
parallel
right, exactly.
and output. So it
Yeah.
essentially, yeah. So for the commit, well, it's the same as for the all other standard, let's say Kafka Iceberg commit. We support exactly one. So that's where you never need to worry about the data duplication, something like that.
Yeah, that's a great thing, right? Because because of the Postgres dialect and the semantics that come with it, you have that kind of consistency guarantees. Yeah, yet you're still running on a streaming platform. That's really cool, right? So,
Yeah. So regarding let's talk about something about the EV, right? Well, and what's unique in the EV industry?
yeah, so generally, we do a lot in the green tech sector and mobility. And the interesting thing about mobility is it's electric mobility is that for the very first time, you have end to end from vehicle to fleet management to everything to grid to all of those use cases. You have like 100% or 360 data collection use case, right? Which was not as possible without a lot of additional hardware in combustion engine use cases, right? Because essentially, an electric vehicle is just a battery on wheels, right? And the battery is equipped with a computer and says a lot about what it does, right? And we've basically it's the interesting thing, right? Because electric vehicles are essentially computers first and then vehicles. And with ICEs, like internal combustion engines, that's pretty much the other way around. And that allows us to monitor and process data in the vehicles and the fleets from the get-go. And that's really interesting because it gives us the ability to just make assertions and observability and implement observability in near real time for fleets and chargers and electricity usage, etc. Right.
So
So
in the EV, the broad layer will be charging station or sensor.
yeah, so yeah, exactly. So if we're looking at the bronze layer, we're basically ingesting raw data that comes from the charging stations, from sensors like telematics devices and others, or even like meters from electricity grids. We just basically collect all that stuff and just pipe it to Kafka.
Mhm.
That's essentially, and we land it so we can do recomputation if necessary. And of course, the landing zone is Iceberg because we want to basically be able to continuously write into an Iceberg table with all of that, right? So exactly. So we're looking at the bronze layer. This is it, right? So we're using a very simple use case of RisingWave. We're basically saying, okay, we're just ingesting the stuff into Kafka. It
Mhm.
goes into RisingWave. RisingWave ingests and writes is essentially the uses its persistence mechanism, a connector to write to Iceberg tables. And we
Yeah.
have, let's say, that bronze layer as is in a table representation, but also externalized as Iceberg tables, so we can just basically expose them anywhere we need. So if somebody wants to run a Spark job or a Flink query on those Iceberg tables, they can just do it, right? So that's a great thing. So it's really open, but yet very efficient.
Yeah, and typically, do you do replication or you do joins, all this kind of
Not
operation?
yet. This is bronze layer. So bronze layer is just about landing, right? So
Okay.
the join stuff happens in the next layer. So if you can just move to the next slide. In the silver layer, we want to have accurate consistent data. So that's what it is. So we're cleaning the data that we get from bronze. We do transformations, and transformation can be essentially, harmonizing data sets, even like stupid things like just changing date formats, or projecting stuff, and essentially harmonizing schemas as well. So that's what we want to do, and that also requires let's say enrichment, in the sense that one use case could be you have a vehicle, you just have a number plate, but you don't have the make or the manufacturing date or the maintenance cycles that you want to enrich the data. Well, you can just do a query in the silver layer continuously, just by just taking the reg plate of that vehicle and then merging into all that additional information that you want to do, you want to have there, right? So that's
Yeah,
stuff that you do
yeah,
in,
yeah.
in silver.
Yeah, actually, I skipped this slide. Well, so basically,
Yeah,
this is an example of the basically the EV data, right? Well, it's
yeah,
basically
exactly right. Yeah,
yeah. Okay,
exactly.
so it looks like this, and then
Yeah,
you actually ingest the data. This is raw data, right? Well, and raw
yeah,
data and into RisingWave. Yeah, basically, yeah, create a source, right? Basically, connect with a source data. Yeah, this is from Kafka. And
yeah,
then
exactly.
you have so basically you create the two sources, and
Yeah.
then you do okay, this is a server layer, right? And you do
Yeah,
all
silver layer. That's
magic.
precisely what I was saying, right? So with stream processing, we
Yeah.
basically have transformation, cleansing, and enrichment, right? As I was saying, and you can just basically do that with declarative SQL, and that's really cool because this stuff was always like I've been doing this for so many years, and we always had to code this bit. It was always a dedicated Spark or Flink job to do that cleansing bit, and now we can just express SQL, and we can express SQL also for relatively complex use cases. With there's one thing in where we basically have to convert Fahrenheit to centigrades, right? Stuff like that, and do that calculation. And you can just do that in SQL rather than having to write like a little job to do that. So it makes it much easier, and also lowers the bar for devs to do that, because since this is SQL, many more people can do this and be efficient with that kind of transformation. And you don't require data engineers to do those and to write those jobs, transformation jobs, and deploy them. It's just part of the package, right?
Yeah,
So it's really cool.
what's this SQL like? What it does?
Hmm?
What this SQL code does?
Oh,
Well,
this
that's why it's
basically
like
creates a continuous a
okay,
sync, right,
uh,
from a
yeah,
select. So we can just basically create a join here. As you can see, we have like very simple select from another select clause. So it's like a nested join, and that basically gives us the ability to sync that data with SQL right into another sync, and that's also a Kafka sync, right?
yeah, definitely. So just a random question. Do you use text to SQL to do this to write this?
Text to SQL.
Yeah, do you use any text to SQL tools as well? I mean, it's definitely
Well,
out
we
of.
could. We could. I mean, this is another thing. That's funny, Lee, is something that I'm going to be talking about, also touching on my next talk on the 15th.
Oh, okay. Cool.
Yeah, the in this case we didn't, but you could, right? You could essentially also just do like text to SQL stuff if you
Yeah.
wanted to. The sky's the limit. So I mean, it's like it's Postgres afterward, right? Yeah.
So yeah. Postgres is definitely eating a word.
Yeah.
Yeah. And about us, okay, now we yeah, we came to the good layer. And
Yeah.
in good layer, we still do all this kind of transformation, right? Well, the aggregation, joins, probably projection, whatever, right?
Absolutely.
So
Yeah. Exactly. And
yeah.
that's
So
the
think that go ahead.
real cool thing, because you can just basically the communication. I mean, if you it's like bogglingly simple, because if you just compare how it used to be, where you have analysts that say, we need the data set, and this is a projection that we need. Hey, data engineers, can you write us a little Spark program that will just deliver that stuff into our Redshift instance so we can do some post processing? That's how we used to do that, and it would take like weeks to implement that, and then back and forth. Oh, is that what you mean? Oh no, that's not what I mean. And you can just test this. You have the deployment pipelines, yada yada yada. Really, really, really difficult to do. Nowadays, with this kind of architecture, it's just about, hey, I need this stuff, and they just write the SQL and try it out. They can just try it out, right? They can say, okay, am I getting what I need? This is like my interface. I can connect my client and just query the stuff. And then you just then say, okay, this works. And you then maybe ask the data engineers to convert that query into a continuous query and land that somewhere. But there you are, right? So it makes the interaction between, let's say, the end users, like analysts or data scientists, uh, like so straightforward, right? The communication bit, the interaction is much easier because we all talk SQL and we have that kind of aggregation stuff, and it reduces also the complex use cases to a few select few. That's why we like to say there's a little 80 to 20 rule in terms of complexity. There's 80% can be done just with SQL, and there's maybe a residual 20% that needs some coding. Well, then you just pop in a program that does that, right?
Yeah, we
And
have the UDF.
with UDFs, exactly, right? Either UDFs, or if there's a bit more complexity and maybe you want to do some fancy large language model stuff, and you maybe just also create something a bit bigger that you plug into. You can also even combine stuff with Flink in order to do that. That's also possible. But that 20% is the stuff where your data engineers really focus on that use case. They don't have to do all the nitty gritty stuff of like endlessly converting the same stuff from A to B, because all of that is handled using like standardized SQL that anybody can actually do, right? So with SQL is so easy actually to learn that it broadens the horizon and the amount of people that actually can contribute to the data platform. I think that's really cool.
Yeah, yeah, totally, totally. Yeah, yeah. So in general, the pipeline looks like this, right? Well, the
Yeah,
entire it's not just a pipeline. It's basically the entire workflow looks like this. Well, the architecture looks like this. Well, so basically, starting from the let's say the charging station, charging stations, your data or sensor data, you ingest into Kafka, right? So
yeah,
and then you land just to do node transformation, right? You just land in the using
yeah,
RisingWave into a brown layer and then do some transformation, whatever, right, way into silver layer. And in order to serve your customers, right, serve your like the internal users, data scientists, whatever, or even applications, right?
yeah.
So you can essentially use for yeah, do another type of transformation aggregation, and everything is like well, everything is streamlined. But it's not like okay, repeatedly doing the exact same thing, same job on the same data set. It's continuous, where it's like an incremental computation. It's
Yeah.
incremental computation. It's not like a tedious. Well, yeah.
No, absolutely not. And the great thing about this, and especially for like, when we've been doing the batch transformation stuff like for a long time. It's the crazy thing is about knowing that, going from left like to right, like from the EV charger ingestion pipeline sensor pipeline to the gold layer is just almost instantaneous, right? Those conversion steps just happen in near real time. Just the latency is just about how long is measured and how long it takes for the different transformation jobs and aggregation jobs to run, right? And that's it. So you don't have to wait like for hours or even days to get your stuff, right? We have one client we're talking to, they're like have a global manufacturing operation, goes from the United States all the way to East Asia. And sometimes, in some cases, in order to pull a report, it takes 48 hours, right? Because they have to wait for the folks in the US to produce the data. They have operations in the UK and India to just, do the post processing. And then once that happens, they have to wait until the batch processing has occurred, and they can be really sure that they have the latest data 48 hours later. And there's no reason to have to take that into account, because if you move from batch to streaming, you embrace the technologies that we've got here, you can get that data set right away, right? Those insights right away. You don't have to wait.
Yeah. Cool. Yeah, essentially we cover basically everything, right? And it's already running on time, and it's already 10:03 in California. So
Yeah,
yeah. Anyways, to summarize, well, I mean, definitely, we can use we everyone wants to move to Iceberg, and we definitely want to have a streaming lake house, especially in yeah, especially in the world where the streaming becomes straight well the mainstream, right?
yeah,
So Rail,
totally.
Rail it can be yeah can be the backbone of your streaming lakehouse. Cool. So yeah, I think that's everything, right? Anything
Yeah,
else? Yeah.
I think that's pretty much it. Yeah, thank you very much. So it was
Yeah.
really great having this chat and talking about like real world like use cases and how to solve them with RisingWave, with Kafka, and with Iceberg.
Yeah.
Very cool.
Cool. Yeah. Yeah. Thanks for attending, and see you probably next week. Probably, yeah, 2 weeks later in London.
Yeah, exactly. Cool.
Actually, next week. Actually, next week
Yeah,
in.
next week, the two of us in Berlin, right? On
Yeah,
the
that's right. Yeah.
15th of May, we have a session. So if you guys are in Berlin on Thursday next week, you're welcome for drinks and pizza and three great talks with Yingjun, myself, and Victor,
Oh
who
yeah,
will
yeah,
talk.
yeah, yeah.
Yeah, that's really great. He's Lake Keeper is a really cool tool for governance. And otherwise, hopefully see you in London at Current.
Sure. Yeah. Thanks. Yeah. See you soon.
All
All
right.
right.
Thank you very
Yep.
much. Bye bye.
Bye.